Good morning. Let's go over the Integrated Math 3 Quiz 12, 511 to 512, April 28th, 2021. All right, which graph is best representation of a normal distribution? Normal distribution, it means that it's symmetrical. It's a normal curve. It has one peak. This one, they didn't do a great job, but this one is a lot of the data is to the left, and this tail over here is to the right. We would call this one skewed right. So not this one. B, this one we would have kind of like two bumps, so we would call this one bi for two, bimodal. So not this one, because it doesn't have that part. Okay, this one, if you cut it in half, this one would be symmetrical in one peak or unimodal or something like that. But you'll notice right here, there should be a kind of a going up right there, so not C. Our correct answer is D. D here meets all of these criteria. Number 2. The graph of which normal curve is most spread out? Most spread out actually refers to the standard deviations. So if you draw each of these pictures, this might actually help you. Okay, so D here with a mean of 82 has a standard deviation of 7. So it goes out pretty far, 7 from here. You know, you subtract 7, so it'd be like 75 and like 89. It goes pretty far, right? But let's take a look at C. This one has one from 5. And the point is that if you have A, this one actually has the smallest spread, or smallest measure of spread, like a standard deviation. This graph is going to look something like this. The spread is really small. It's only 0.8 from the center here, which means the blue, this is the largest. So our answer for number 2 is D. Number 3. Normal curves X, Y, and Z represent the wait times in emergency rooms of 3 different hospitals. Which statement must be true? Select all that apply. So this can be 1, 2, 3, or 4, all of them. That's what I'm trying to say. Okay. Let's talk about these curves here. Let me see if I can color code them for you, and this might help. Okay, X is here. And if you think about X, what's just going to happen is it continues on, and it keeps spreading out there. Let's do Y is the middle one. And we'll call Z the yellow. Okay, so I want you to notice that they all have the same measure of center, which is the mean. This is the mean, the red dotted line, okay? Because it's all right here in that dotted line. But what's different is each of their spreads are different. So let's write down those facts, okay? Same mean, different spread, or variation we call it. Remember, like jam? Okay, so all three hospitals have the same mean wait time in the emergency room. That is actually true. Let's change colors here. I'm going to put a check mark by trues and X's by false. Hospital Z, Hospital Z has the longest wait time in the emergency room. I actually think this should be the least or smallest or shortest. Because if you look at Z, you're ending up on the yellow here, smaller than the blue. The blue is going to keep going out way out here. So I've waited in the emergency room before. Do you want to do 10 hours or maybe like 6 hours? There's a difference there, right? So not this one. Okay, Hospital Z has the least or smallest standard deviation, or a simple word is spread. And that is true. So you look at the yellow jam, right? It's smaller, shorter in distance. Blue goes way out there, so that one is true. Okay, the range is basically max minus the min. So that's just kind of like how far the two spread out. Let me see if I can annotate that in a different color. Okay, so the spreads are the range is not going to be the same. So this is a minimum. That's like a low number. Let's just say that's like, I don't know, 2 hours. And then over here, distance between the two blue dots. The blue dot on the right, this would be like a max, and this one will be a minimum. So they're saying, are the distance between these two dots the same thing as the distance between the two green dots? And we would say no. And we would say, is that the same distance as the two dark blue dots? The answer would be no. So our answers are going to be A and C for number 3. All right, number 4. What are the mean? Remember the symbols for mean here? That's a population mean. It's like a U, and then on the left side is a super long tail, and this is a measure of center. And standard deviation is a circle with a tail, and this is a measure of spread or variation. Okay, so where is the center? The center is where this peak is. So this is my mean, 40. Yes, yes, no, no. Okay, standard deviation is just the distance going either right or left, and it doesn't matter. So if you did 130 minus 140, you would get negative 10, but we would come take the absolute value. So our standard deviation is actually equal to 10 in this problem. This one was 140. Let me show it to you a different way. This way you are subtracting 10, right? And this way you are adding 10. And you'll notice that you keep the number is 10. So standard deviation is never negative. Let's write that. Never negative. All right. So which one has one that's 10? Here and here. 30 is not correct. This 30, they're probably getting that number from 140 to 170, all the way there. That would be wrong. This would be 3 standard deviations. Okay, which one has 2 check marks? That would be 4 is A. All right, let's go on to the next one here. Oh, didn't want that to happen, but it did. The table displays the ages of current employees at the ACE Software Developmental Company. Okay, so you have a company and you look at the employees and basically you ask them, how old are you? And then you do a tally mark. All right, so between 21 and 30-year-olds, there's 13 people, and then 22, 8, 5, and 2. If you construct a relative frequency histogram, okay, so frequency just means count, and then the relative basically means we're going to turn into a decimal. Okay, so if I add all of these employees here, I have 13 plus 22 plus 8 plus 5 plus 2 gives me a total of 50 employees. Okay, this is perfect. 50 is a great number. Okay, so essentially what you're doing, so this is the total, and this is 13 out of 50, 22 out of 50, 8 out of 50, and 5 out of 50, and 2 out of 50. Let me teach you guys a shortcut, or just some good math. If I just multiply denominator and numerator by 2, you get 26 out of 100. Why is that important to us? It's because that's what the word percent means. Per cent. Well, how many pennies are in a dollar? 100. So it's out of 100. So essentially what you do is you just have 0.26. Double that, you get 44 over 100, which is 0.44. And you can put that in a calculator. Let me show you really quickly. 8 divided by 50. Boom. Whoops. Turn it to a decimal. 0.16, right? So let's double it. 16 out of 100. Does that make sense? All right. So 10 out of 100, which is 0.10. And this one's going to be 4 out of 100, which is going to be 0.04. So again, the totals, let's do this in red here. You're going to have 50 over 50, 100 over 100, which is equal to 100%. Okay? Okay, so we may not even have to create a histogram, but we definitely had to change them into decimals. Let's see. If you construct what will be the height of the bar representing the 40 to 50-year-olds. Okay, 40 to 50-year-olds is this one right here. And, okay, here's the mistake, right? You think 8 or 8 over 50 is going to be 8%. That's wrong. It's 16 out of 100.16. And that would be choice B. Okay, C is wrong because this is just the frequency. I would say wrong decimal. And D is wrong because although they doubled it, right, 16 out of 100, they forgot to divide it by 100. Needs to divide by 100. So that's wrong. Okay, let's move on to the next one. Number 6. The heights of a large group of women are normally distributed. Okay, normally distributed basically means you just draw the normal curve, the distribution curve, the ghost. Okay, with a mean of 65, so this mean here means it's the center. And a standard deviation of 2, which basically means if you keep adding 2, you will get 67, 69, and 71. And if you keep subtracting 2 from 65, you will get 63, 61, and 59. Okay? Okay, so if a woman is selected at random from a group, what's the probability that she is? Remember, probability is just a number between 0 to 1. If she is 61 to 67. Okay, so here we just have to review something. The normally distributed just basically means I have to do the normal curve. I have 68. Do you guys remember this? Is between one standard deviation. If you cut that in half, then you'll get 34 and 34%. Okay, so if I do this right here, let me see, I didn't really note it, but let's put that in with orange. This is 1 standard deviation away, and this is 2 standard deviations away. 1 standard deviation away, 2 standard deviations away, or below, we say. Okay, so we just established that 1 standard deviation away is 34% and 34%. Okay, so if I do 2 standard deviations away, that's the center. 2 below, 2 above. We would say the whole distance is 95%. And half of 97 is 47.5%. Okay, so let's kind of review what we got so far. But here, I kind of need to know if I know that this portion, I chose a bad color, let's do yellow. If yellow here is 34%, yes, 1 standard deviation. And in yellow is the 34, that's 1 standard deviation. How much is this blue area? One of these blue areas. Well, if I know that this is 34, this is x, I can just do x plus 34 equals 47.5%. And if I subtract here, I will get x to be 13.5%. Let's highlight that in a color. Okay, why did I need to know that? Because I need to know this area, which was the green, and we did 2 yellows, so that's 34. So now I can go back and say, well, this is 13.5. So if I add those 3 numbers together, 34 plus 34 plus 13.5, I get 81.5. So all of this area green plus yellow is 81.5%. And 85.1%. Maybe I messed up on my numbers here. Let's think, 95 divided by 2, 47.5. 47.5 minus 34 is 13.5. 68 plus 13.5. 81.5. Well, I think the closest one would be choice B. Last one, number 7. A laptop, let's draw our normal curve because we're going to see this ghost again, has a mean life of 9 hours. This is our center. And a standard deviation of 0.3. Remember, I just need to keep adding 0.3s. So that would be 9.3, this would be 9.6, and this would be 9.9. And if I subtract 0.3, I would get 8.7, and subtract it again, I get 8.4 hours. Determine the percent of laptops with battery lives of 0.84 and 9.6. Okay, so they basically want to know what's this whole area in yellow. Now remember, how many standard deviations did we do? We did 1, 2. Going to the right here, this is positive 1, 2. Okay, I'm going to make a disclaimer here because so here is 2 standard deviations away. Okay, so this is not 4 standard deviations. Okay, we basically say this is 2 standard deviations away from the mean. We call this 2. Just look at this number there. That's the best one. So in the empirical rule, you have 68, 95, 99.7, and this is 1 standard deviation, 2 standard deviations, 3 standard deviations. So we're just looking for one that has 2 standard deviations, which would be 95%, and 7 is your answer is C. And that's it. That's what we have for quiz number 12. We'll see you guys later. Bye.